Okay, so we're on 5.3 part 2, and you should have your little unit circle to help you with this lesson, and you should have already filled it out according to our last video. So we're going to do a couple more types of problems to solve, and we're going to start with number 1. Now, number 1, we cannot factor this because we have a sine and a cosine. It's like having an x and a y in a problem. So a technique that we can use is we could convert everything to one trig function. Like I know that sine squared is 1 minus cosine squared. Okay, then I can distribute this 2. And I can combine like terms. So I've got negative 2 cosine squared plus 3 cosine minus 1. Now, I typically don't want a negative in front of my highest exponent, so I'm just going to divide it out by changing all the signs. Now, you can do the 4-step method or you can do guess and check. But when we factor this, this gives us 2 cosine of x minus 1, cosine of x minus 1. And then our next step is we set both equal to 0 and solve. So I'm going to set 2 cosine of x minus 1 equal to 0 and cosine of x minus 1 equal to 0. So this would be cosine equal to 1/2 and cosine equal to 1. So now I'm going to use my unit circle to help me out and find the answers. So first I want to find where cosine is equal to 1/2. So cosine is the x value, and cosine is equal to 1/2 at pi over 3, and it's also equal to 1/2 at 5 pi over 3. And cosine is equal to 1 at 0. And for all of these, we're going to add a 2 pi n because cosine repeats every 360 degrees, so there's definitely more answers than just those 3 that we found in the first 360. Okay, next let's try number 2. Find all solutions of cosine plus 1 equals sine on the interval from 0 to 2 pi. So for this one, we do not have to add a 2 pi n to this. Okay, so one technique that we can do, and we're going to try that with this problem, is that right now we have 2 trig functions, and neither of them are squared, so I can't really just plug one in for the other. But what I can do is I can use the technique where what we do to one side we have to do to the other side. And one thing that we can try to do is square both sides. Now the left side I can FOIL this. So if I write this twice and FOIL, that would give me cosine squared plus 2 cosine plus 1. And the right side gives me sine squared. Now, I can now convert sine to cosine because sine is equal to 1 minus cosine squared. And now I'm going to move everything to one side. So if I add the cosine squared over, that gives me 2 cosine squared plus 2 cosine. And if I subtract the 1 over, that gives me 0. So that equals 0. Next, I'm going to keep solving. So now I can factor out a cosine. That would leave me with 2 cosine of x plus 2. Or I guess I could have factored out the 2 cosine as well. So if I factor out the 2, let me change this. That would give me cosine of x plus 1. Either way, I'd get the same answer. So now we're going to set both equal to 0. I'm going to set 2 cosine of x equal to 0. And I'm going to set cosine of x plus 1 equal to 0. And now we're going to solve. So if I divide by 2, I still get cosine equals 0 over here. And over here I would get cosine equals -1. So now I'm going to look at my unit circle. First, let's start with a 0. So cosine is the x, and I want to know where cosine equals 0. And that would be at pi over 2 and at 3 pi over 2. And those repeat every 360, but we're just looking at the answers between 0 and 2 pi, so I don't have to add that in. And I also need to know where cosine is equal to -1. So cosine equals -1 at pi. Now, we do want to check our answers into the original problem to make sure that they are correct. Now, this one actually is an example of a time where we're going to get an extraneous solution. And if we check each of these, like this one, pi over 2, the cosine of pi over 2 is 0. 0 plus 1 is 1. Sine of pi over 2 is 1, so that works. If I check pi, cosine of pi is -1 plus 1 is 0, and then the sine of pi is 0, so that works. But if I check 3 pi over 2, the cosine of 3 pi over 2 is 0. 0 plus 1 is 1. And then the sine of 3 pi over 2 is -1. So that actually does not work. That's an extraneous solution. So you do want to make sure you check your answers to see if they all work. And you can use your graphing calculator. Just plug it right in, make sure you're in radians, and see if the one side gives you the same decimal as the other side. Okay, let's go on to number 3. We have 2 cosine of 3t. Now this is the first time we've seen something like this, where we have not just an x, we have a number with our x. And we're going to solve this just like we normally would. So I'm going to get the cosine by itself. So I'm going to add the 1 over, and then divide by the 2. And for now, I'm going to solve this using my unit circle. I'm going to kind of ignore that 3 for now. So I'm going to look for where cosine, which is the x, is equal to 1/2. So that would be at pi over 3. And it would also be at 5 pi over 3. So I've got 2 answers so far. I'm going to write those down. Pi over 3 and 5 pi over 3. Now that's normally we'd say x equals, but here it's 3t equals. So that means we've got one more step to do. We've got to now solve for t, meaning I've got to divide by 3. So t would equal pi divided by 3 gives me pi over 9. And that would give me 5 pi over 9. Now, normally we would add a 2 pi n after both of these. But that's again for just x. So these also have to be divided by 3. Okay, so let's try number 4. Number 4, we have 3 of tangent x over 2 plus 3 equals 0. So I'm going to solve for tangent. I'm going to subtract 3 from both sides. And then divide by 3. Okay, so now I'm going to solve for tangent. So I want to know where tangent would equal -1. So when I divide sine by cosine, I'm going to get -1 down here, over here at 3 pi over 4 and at 7 pi over 4. But remember, tangent only occurs between 0 and 180, so I don't really have to worry about the 7 pi over 4 because that's going to get repeated. If you add it in, it's not a big deal. It's just an extra answer. And you would get that anyway with the pi n that we're going to add. But the one answer for sure is 3 pi over 4. So I'm going to write x over 2 equals 3 pi over 4. So now I'm ready to solve for x. Got one more thing to do. So x would equal, and to solve for x, I'm going to multiply by 2. So 3 pi over 4 times 2 would be 6 pi over 4, which would be 3 pi over 2. And normally I'd add a pi n, but we're going to multiply that by 2 as well, so plus 2 pi n. Okay, let's go to number 5. We're going to find all the solutions of secant squared minus 2 tangent equals 4. So I see right away I have a secant squared, and I know from my Pythagorean identities, secant squared is 1 plus tangent squared. And I'm going to move that 4 over to the other side by subtracting it. Okay, so if I combine like terms, I've got tangent squared minus 2 tangent minus 3. So hopefully I can factor this. So I'm going to set up my 2 parentheses. I'm going to put tangent first. And I've got factors of 3 that subtract to give me 2 would be 3 and 1. Different, bigger one's going to be negative. So I'm going to set each of these equal to 0. So over here I'm going to get tangent equals 3. And over here, tangent equals negative 1. Now, first I'm going to start with the negative 1. That's the easier one. So where would tangent be equal to negative 1? So that's any time where sine divided by cosine gives me negative 1. And again, I'm only looking in the first and second quadrant. So I would be over here at 3 pi over 4. And I'm going to add a pi n to that. Okay, now this next one here, this one's a little bit trickier because that is not something that we're going to find on our unit circle. So what we can do instead is we can use our graphing calculator to give us an approximation, but this does not say approximate, right? So instead we're going to write this out. So if I wanted to solve for tangent, I would use an inverse tangent. And hopefully you remember the symbol for that. That's the little negative 1. Or you can use arc tangent. So we can write our answer as arc tangent of 3 plus pi n. So remember, these are actual answers. They're not approximate because we did not get a decimal. So we're actually going to do an approximate answer for this last question. It says approximate the solutions of x equals 2 sine of x in the interval from negative pi to pi. So for this one, we're going to want to graph this because that means we can get a decimal. And make sure your calculator is in radians. Now, to graph this, there's no y. So what I'm going to do is I'm going to move everything to one side. So we would have x minus 2 sine of x equals 0. So on your calculator, you would put that into your y equals. So go ahead and I'll give you a few seconds to type that into your y equals. And again, make sure you're in radians. Okay, so I've got my calculator here. I'm going to plug in x minus 2 sine of x, and I can see at the top I am in radians. Now, it's probably going to be a good idea to change our interval to the interval that we're interested in. So I'm going to go to my window, and I'm going to change my x-min to exactly what my range is here. So I'm going to go negative pi, and then pi, and then hit graph. So now I'm just looking at the section that I need. And we want to know where it equals 0. So anytime a graph equals 0 is where it crosses the x-axis. So we're going to have 3 answers here. So I'm going to say x is approximately. So let's go with our first one here. So I'm going to go second trace, and that's a 0. I'm going to go to the left of where it crosses, to the right, and then take my guess. Negative 1.895. I'm going to do the same thing with the one in the middle. I'm pretty sure it's 0, but I'm just going to double check. You can also just use your table of values if you think it's a whole number. That'll save you some time. And that gives me 0. And then my last one, left, right, and take a guess. That gives me 1.895. So if ever it says approximate, that means you can use your calculator and you can get a decimal answer instead of using the unit circle. But you want to make sure you're careful about that. It has to say approximate for you to be able to do that. Okay, so that concludes our last lesson of solving trig equations.